Hello viewers, welcome to UVolve, the channel for database and data professionals. In this tutorial, I am going to demonstrate how to upgrade a single instance Oracle database from release 12.1 to release 19.3 without using the graphical user interface or GUI. So viewers, this method is useful when you cannot access the graphical user interface of the Oracle Database Upgrade Assistant or DBUA due to unavailability of X Windows system or cannot use other means like OEM, etc. So the manual upgrade activity consists of 4 broadly categorized steps. Number 1, the prerequisite steps. Number 2, pre-upgrade steps. Number 3, upgrade steps. And number 4, post-upgrade steps. First, the prerequisite steps. OS and DB version compatibility metrics from MOS. It means if you are upgrading your database from say 12.1 to 19.3, then whether your target version 19.3 is supported in the current OS platform or not, or whether the 12.1 database can be directly upgraded to 19.3 or not. These things need to be checked beforehand. I have a separate video on how to check compatibility and certification metrics in my Oracle support. If you want, you can watch that using the link in the description of this video below. And once your upgrade compatibility matrix is verified, next, check application compatibility with the new version of Oracle database. Of course, you need to check this with the help of your application team or application vendors. Once all the compatibility checks are successful, download the target RDBMS software version, in this case the 19.3 software, which I have already downloaded and installed in my database server. I have a separate video on download and install Oracle RDBMS software version 19.3 on a Oracle Linux 7.9 platform. If you want, you can watch that using the link in the description of this video below. Once all the prerequisite steps are done, we will move to the pre-upgrade steps. But before I start the pre-upgrade steps, let's take a look into the database and OS environment that I'm going to use. For this demo, I am going to use my virtual environment created using Oracle VirtualBox virtual machines. If you want to create your own virtual environment for learning database, UNIX, Linux, or networking, etc., please watch my series on Oracle VirtualBox virtual machines using the link that I have given in the description of this video below. Also, I am sharing all the steps that I'm using in this demo, along with any sequels or OS commands in a shared document in my Google Drive. You can copy them using the link in the description of this video below. Now, let's start. So this is my virtual server named admin SVR with 64-bit Oracle Linux 7.9 installed, and I have logged in as Oracle user, who is the owner of all Oracle installations in this particular server. And this server already has a couple of databases created under Oracle version 12.1 and 19.3. So first, let's take a look into the Aura tab file contents. And here we can see that the database named OEM repo, which belongs to the Oracle 19.3, and the second one named ORCL CDB is also from 19.3, and the last one named ORCL X is with the version 12.1, and this is going to be our candidate database to be upgraded to version 19.3. Now we will start with the pre-upgrade steps. The first pre-upgrade step is to backup the database before performing any kind of upgrade activities. The full database backup is highly recommended. You can take additional backups like export or file system or storage level backups, but an ARM and full backup is a must. In my case, as it is a virtual machine, I have already taken a backup and also a snapshot of the virtual machine. Next, we need to check the table space sizes and the free space available in them. Make sure to have good free space for the system and CSOX table spaces, and they should have at least one data file with auto extend on. If you don't want to enable auto extend, then at least 2 gigs of free space on each of the table spaces, and a fast recovery area or the archive location should also have at least 5 gigs of free space to accommodate the archive logs and the flashback logs that we are going to generate. You may need even more free space in the FRA if you want to retain your flashback logs for a longer amount of time. Now let's first set the environment for the database, and then we will log into the database as sysdba. And the first command that we are going to use is to check the status of the table spaces. I'm just copying and pasting the commands to save time and avoid making any mistakes. Again, these all commands are available in my Google Drive. You'll be able to copy them if you want. So we see that our sysocks and system table spaces have around 91 MB and 2 MB free respectively, but they have auto extend on, and also it will be extended up to max 32 gigs. So we are good with it. Next, we'll check the invalid object counts in the database. The count of invalid objects should be 0, and if not, at least the number of invalid objects before and after the upgrade should be the same. It means the upgrade activity should not introduce any new invalid objects in your database. So we'll use this command, and we see that the number of invalid objects is 0. And the next pre-upgrade step is to gather the dictionary states. So I will use this command, which I'm pasting here, that is execute dbms stats.gather dictionary states, which is going to take around a minute or so. And as we can see, the dictionary stats have been gathered, and it took around 58 seconds. And the next thing we need to do is to parse the DBA recycle bin. So simply using the command parse DBA recycle bin, we will parse the recycle bin, and it is done. Then we need to refresh all the materialized views, if any, in your database prior to the upgrade activity. So we are going to use the command that I am copying and pasting using the dbms mview package, and under that refresh all mviews. This particular procedure we are using to refresh all the mviews. And as there are no mviews in my database, it quickly finished. In your case, this may be different, and based on how many materialized views you have in your database, this may take a couple of minutes to even hours. Next, we need to verify the archive log destination size, or the fast recovery area size, which is going to hold our archive logs and flashback logs while creating the guaranteed restore point. So first of all, we'll check whether the database has been in archive log mode. Yes, it is in archive log mode. And then we'll check what is the size of the recovery dest. So show parameter recovery, and it gives us the FRA size of 10 gigs, but also we need to validate how much free space is there in that file system. So we'll use the command host df-h, the fast recovery area destination, and we see that the file system has around 19 gigs free. So we are good. Now also we need to validate what percentage of the fast recovery area is actually used and what percentage is free. So I'm going to use this SQL statement to find out the fast recovery area available space, and we see that the limit size is 10, used GB is 0, reclaimable is 0, and available is also 10. It means all the 10 gigs are free for us, so we are good. Next, we need to check whether the flashback database is enabled for the database or not. Using select flashback on from database, and we see that the flashback database is not on, so we have to turn it on. So we'll use the command alter database flashback on, and then we'll check it back again, and now it is on, or yes. Next, we will check a couple of more parameters and values for the database. First of all, the open mode and log mode of the database. Anyway, we have checked already, the archive log mode was on, so this is going to be archive log only, but the open mode is also in read write. This is important. The database cannot be in any other open mode. Then we'll check the parameter compatible, and we see that currently the compatible parameter is similar to the version of the RDBMS software, that is 12.1.2. And then we will check if there is any restore point already created. If there is any restore point, we need to drop it first before creating the guaranteed restore point that we will use for the upgrade activity only. So we'll use the command select star from $restore point, and it did not return anything means we don't have any restore points created in the database. So we will create a restore point using the command create restore point pre-upgrade guarantee flashback database. So the restore point has been created. Now we'll check back the status of the restore point again using the command select name guarantee flashback database time from $restore point, and it gives us the output for the restore point that we just created. And next we need to run the pre-upgrade script, which is actually an OS script and has to be run in the OS prompt as Oracle user, which is the owner of the Oracle installations. So we'll exit from the SQL prompt. Let's clear the screen, and then I'll show you the content of the Oratab file one more time. Let's see Oratab, and here, as explained before, this is our source database to be upgraded, which belongs to the Oracle home, that is 12.1, and we'll be upgrading to 19.3, and the Oracle home is this one. So we have to export two environment variables for the ease of operation with these two values of the Oracle home. The first one is the source Oracle home that I'm setting to this 12.1 home to the variable source underscore Oracle underscore home. And then I am exporting another variable as target Oracle home that is set to the 19.3 home. Now the command that we are going to use is the pre-upgrade.jar file that belongs to the 19.3 home, and to do that we have to use both the homes, which will actually check the pre-upgrade feasibility for the upgrade operation. So we'll use the command the source Oracle home, that is the 12.home, and under that the jdk bin java -jar, and the script that we are going to actually use belongs to the 19c home, which is coming from the target Oracle home /rdbms/admin/pre-upgrade.jar, and the file directory is actually specifying where the output of the pre-upgrade will be logged. So once we hit enter, this pre-upgrade script will run. That will take around a minute or so, and the pre-upgrade script has been successfully completed, and it has given us some important information as a summary. That is the pre-upgrade summary, where we can see there's a log file, there's a pre-upgrade fix-up script, and there is also one post-upgrade fix-up script, and also some instructions about how to run the fix-up scripts. So before the upgrade, we have to run the pre-upgrade fixup.sql script, and after the upgrade, we have to run the post-upgrade fixup.sql script. But before we run these scripts, first let's take a look into the pre-upgrade log file. So I'll use the VI editor to open this file. It has given the details about the source database and the target database version, that is the upgrade to version is 19, status of the database prior to upgrade, the source version that is 12.1, DB patch level, no patch bundle has been applied so far, compatible parameter that we have checked already, block size, platform, time zone file is 18, which is of course an old time zone file, and we are going to take care of that once the upgrade activity is completed. Database log mode, read only, addition, etc. And the components that we have in our database are all in valid state. This is important because if there is any invalid components, you have to take care of that before the upgrade, so that it does not create unnecessary confusion whether the upgrade activity has introduced any invalid components. And let's scroll down. Before upgrade, it is giving us instructions about any actions to be taken before the upgrade, and as we see, none, so we don't have to take any actions particularly. And below we see this section, information only, and it gives us all the components and their current version and current status, etc. Scroll down, the table space size information that we already validated. We have enough space for this upgrade activity. Also, it is recommending to take a backup. As I mentioned already, we must have a valid RMAN backup, and the invalid objects that we already checked, we don't have any invalid objects, and also there is no invalid objects that belongs to any application schemas. Let's scroll down, and after the upgrade, although there is no required actions, but there are a couple of actions recommended. The first one is to upgrade the time zone file that I just mentioned, as we found it as 18, which is very old, and we have to update the time zone file or the version once the database upgrade activity is completed. And then it is recommending to gather dictionary states, and it is actually a good practice to gather dictionary states once a major activity like release update or database upgrade activity is performed, because that may introduce new dictionary views, etc. So it is important to gather stats on that. Then also it is recommending to execute DBMS stats package to gather fixed object states. This is also a very important activity that we need to take care once the upgrade activity is completed. And that ends the log file, and we will take care of each of these recommendations manually where an auto fix-up is not specified after the upgrade activity as per the order in which they are specified. So let's come out of this log file, and next we will run the pre-upgrade fix-up script, which is a SQL script. So we have to again log into the database as sysdba, and then we will simply copy paste the script that is given in the output above. So @ and the path to the pre-upgrade fix-up script. Press enter, and this script has fixed any issues that needs to be fixed before the upgrade activity starts, and it has given us a summary. We see that the action items are just informational. Actually, it didn't have to fix anything. Most of the issues that needs to be fixed before the upgrade are actually fixed by the pre-upgrade fix-up script. And in your case, based on the database status, install components, etc., it may give us a different set of suggestions. And if the pre-upgrade fix-up script is unable to fix those issues, you have to manually take care of them. Usually, the instructions to fix those issues are also provided by the pre-upgrade fix-up script. For example, in my test database, I don't have Oracle Application Express or Apex installed. Usually, when you do a manual upgrade, it is unable to upgrade the Apex automatically, unlike the DBUA or GUI upgrade. So in that case, you have to manually upgrade the Apex before continuing with the database upgrade. I have mentioned the steps to upgrade the Apex components in the description of this video below. If you want, you can follow those steps to upgrade Apex beforehand. Now all our pre-upgrade steps have been completed, and we are ready to perform the upgrade steps. So first of all, we will shut down the database using the shutdown immediate. Let's exit from the SQL prompt and clear the screen. Next, we will copy the password file from the old Oracle home to the new Oracle home, that is the source Oracle home 12.2 to the target Oracle home, that is 19.3. And the password file always belongs to the DBS location. Press enter, and that has been copied. Similarly, we have to copy the SP file from the source Oracle home, that is 12.1 home, to the 19.3 home, and that has been done. Now let's go to the target Oracle home, and under that the DBS location, and we'll see if the files are there. And as we can see, the password file that belongs to the ORCLX database is copied to the new home, and also the SP file that belongs to the ORCLX instance is copied. Next, we need to set a couple of environment variables. I am just copying and pasting, and then I'll explain. The first one, that is the Oracle home, that is nothing but the 19.3 Oracle home, or our target Oracle home. Then the LD library path is nothing but the lib directory under the new Oracle home. Then Oracle SID, that is the ORCLX as mentioned before. The TNS admin, this is also important, and this is going to be our new TNS admin folder under the 19.3 home, that is Oracle home network admin. Then the path variable that will have all the new paths that belong to the 19.3 home. Then we'll start the SQL Plus application as sysdba, and as expected, the instance is idle because we just brought it down, and now we will start up the database using upgrade mode, that is startup upgrade. And the database has been started, Next, we will execute this select statement to get a few values about the name, open mode, CDB, version, status, etc. And the name is ORCLX, open mode, read write, CDB, no, because this is not a container database, version is 19.0, and currently the status is open migrate. So we are in the migrate or upgrade mode. Now let's exit from the SQL prompt, and then we will go to the Oracle home bin directory, clear the screen, and we'll go to the bin directory under the 19.3 database home. And under that, we'll locate one particular script called DB upgrade using lslrt. Yes, this is the script. And we will execute this script in background using nohub. It is because if due to any reason your OS session to the server is disconnected, the upgrade activity will still continue in the background. And this command is nohub./dbupgrade %. Press enter again, and the job has been created. And we can list out the background jobs using jobs-l command. And this is currently running. And also we can get the status of the background process related to this DB upgrade script using psef-grep-i catctl.pl. This is the Perl script which is running behind the scene. Press enter, and we see the process which is executing this particular Perl script. And actually we can also monitor the nohub log using the more command, that is more nohub.out, which is in the current directory. And you can see a lot of information have been logged already. But the most important thing is we need to monitor the upgrade logs. And to find the upgrade logs, we have to go to a specific location under the database home, which is called the CFG tools logs. And I'll just clear the screen first. And then we'll go to the directory named CFG tools logs under the 19.3 home, and under that the ORCLX subdirectory. Let's list out everything inside, and there's another subfolder named upgrade along with the date and time that we started our upgrade activity. Let's go inside it, and we will list out everything inside this subdirectory. And these log files at the end are of utmost importance. The last log file, that is cat upgrade 0.log, will give us the actual upgrade status. So we will do a tail -f of this file to dynamically list out all the lines that is getting generated. Press enter, and we see it's going on very fast. So this script is going to take around an hour. So I will pause the video and I'll resume once we see that the scroll lines are stopped and we get a summary of the upgrade activity. So it has been over an hour now, and we see this is 1 hour and 9 minutes and 47 seconds that the script took. And we see the summary of the script where all of the components were upgraded except the Oracle Real Application Cluster, which is switched off because it's a single instance database. Now we can hit Ctrl+C to come out of the tail command. Now we have a few more steps to perform as a part of this upgrade activity and before the post upgrade activity starts. So first let's clear the screen, and then I will log into the database as sysdba, and it says it is connected to an idle instance because currently the database is actually down. So we will start it up using startup open. Please note that our environment variables are already set in this session, and we are actually connecting to our database with SID ORCLX. So the database is opened. Now we will validate one more time all the components that belong to this database. First of all, we'll check the open mode and the status of the database, and we see now the open mode is again read write and the status is open. Unlike the last time when we saw the status was in open migrate state. Now the next thing we need to do is to validate the components. Although it has been already listed in the summary, we can see that all the components have been successfully upgraded except the real application cluster, which is not an option in this particular database. And now we are ready to perform our post-upgrade steps. So let's exit from the SQL prompt. And the first thing we need to run is to recompile all the objects in the database using the utlrp.sql script, which is found under the Oracle Home RDBMS admin directory. Again, clear the screen and go to that particular directory, that is our 19.3 Oracle Home, under that RDBMS and admin directory. And we need to run the utlrp script in the background because this is going to take some time and it is going to compile thousands of objects. And as mentioned before, so that in between, even if the OS session disconnects, our activity still continues, we will run this utlrp script in background using the command nohub SQL plus as sysdba, running the utlrp script because we are already in the directory, and the output will be sent to the utlrp.out under the home directory of the Oracle user, and then press enter. So a job has been created to run in the background, and then we'll keep on checking the count of the invalid objects and whether they have been reducing in numbers, and that will actually give us an indication that the script utlrp is working behind the scene. So we'll connect to the database again as sysdba, and first we will run the total count of the invalid objects. We see this is 7,234. Let's wait for a couple of seconds and then run it again. And now we see that it is 7,024, means 200 objects were just recompiled within a couple of seconds. So our script is working behind the scene. Also, if you are interested to see only the objects that belong to sys and system schema, you can execute another query where the owner is sys and system that we specified, and we see that the number of invalid objects currently are 2,488, and if we execute it again, it should reduce. Yes, this is 2,305. So this script is working very fast and we should be done in a couple of minutes. There is also another query that can be used to find the status of the invalid objects, and that is using this particular view called obj$, which is owned by the sys user, and the status in 4, 5, and 6 means the object is in an invalid state. So we see that the current count is 347, so it is ever decreasing. Let's run it again. 211. I will pause the video and I will resume once I see this count is 0. Let's execute it again. Count is 15 now. So it has been almost 2 minutes. Let's check the status again. And now we can see that the invalid object count is 0. Also, let's execute the first query. And yes, it is 0. Now we are ready to run the post-upgrade fix-up script that was recommended by the pre-upgrade tool. First, let's exit from the SQL prompt. And also you can see that the recompilation job that was running in the background has been completed. Let's clear the screen, and then we will log back again as sysdba. And this time we will run the post-upgrade fix-up script. If you lose track of this script location, just open the log file that was produced by the pre-upgrade tool. You'll be able to see the location of this file. So I'm going to run this. This takes around 3 minutes. I will pause the video and I'll resume once we see the final output of this script. So after around 3 minutes, the post-upgrade fix-up script has been completed, and we see the summary where all the auto fix-up action items have been completed successfully, and there was actually just one auto fix-up item, that was the post dictionary. And under the pre-upgrade issue is remediated column, we see that the status is shown as yes, and we don't need any further DBA action. But item number 6 and 8, that is for the old time zone exist and post fixed objects, these two items we have to take care manually. So to update the time zone file, we are going to first find out what is the current time zone file version. Using the SQL command, select version from $timezone file, and this is going to be 18, as we have seen this before in the pre-upgrade logs also. And then we are going to execute the command from the new 19c home, that is utltg upgrade check.sql, which is from the 19.3 Oracle home. So the first script to check the status has been completed. Now actually we are going to run the next script to apply the updates. That is again running from the RDBMS admin home under the new Oracle home, and the script is utltg upgrade apply.sql. And this update is going to take around 3 minutes again. I will pause the video and I will resume once the script is complete. So after around 3 minutes, the time zone file update has been successfully completed, and the database has been also restarted by the script, as we can see in the output. Now let's check the time zone file version one more time. Earlier it was 18, it should be a recent version. Yes, we see it is now 42. So our time zone file has been successfully updated. Now we'll run one more script to produce the status of the upgrade activity, that is the utl usts.sql, which is also found under the Oracle home RDBMS admin folder. So I'm just pasting the script here, and the output will be produced as a text file. Press enter, and we can see the status of the individual components. And we'll run the cat uppst.sql script. This script actually completes the remaining part of the upgrade process, which does not require the database to be in upgrade mode. So I'm just copying and pasting. The file is available under the RDBMS admin directory. Press enter, and it has given us the final status. And next we will run the post upgrade fix-up script one more time to make sure that all the issues or the action items have been taken care. So I'll again copy paste the post upgrade fix-up script along with its part, and we see that the item number 6 and 7 are both marked as yes. Now the final step is to gather statistics on the fixed objects. So before running the gather stats on fixed objects, we will set the timing on. We come to know how much time it has taken, and then we'll execute dbms stats.gather fixed object stats. Hit enter. Okay, so after around 5 minutes and 9 seconds, the gather fixed object stats has been successfully completed. Please note that this is an optional step and it is given just for information only, but it's a good practice to gather the statistics on the fixed objects or the X dollar tables owned by sys user after an upgrade. Now I'll check the invalid objects count one last time to make sure that it is 0, and yes, it is 0. And then we will drop the restore point that we created before the upgrade. Please note that this is optional. If you are 100% confident that your upgrade activity has been successfully completed, you can drop the restore point to save some space in your archive or fast recovery area location. So we will check the guaranteed restore point that we created with the name pre-upgrade. Then we will simply drop that restore point using drop restore point pre-upgrade, and it has been dropped. Let's check back again. The query should not return anything. The last thing we need to do as a part of the post upgrade activity is to set the compatible parameter with the appropriate value. As currently our compatible parameter is still in the old version, that is 12.1. So let's do a show parameter on the compatible parameter, and we see that it has a value 12.1 and we should be setting it to 19.0.0. So we'll update this parameter in the ASCII file first, because this is not a dynamic parameter and the database needs to be bounced for this change to take effect. And then we will shut down the database, and then we will start it up again, and then check the compatible parameter again using show parameter compatible, and now we see it is in 19.0.0 version. Now we'll check the DBA registry for the status of all the components using the select component ID, component name, version status from DBA registry. And we see a nice picture there. And then the last thing we need to do is to modify the Aura tab entry to reflect the new Oracle home. So let's exit from SQL Plus. Let's clear the screen. Then we'll do a VI on HC Aura tab. And we have to update the Oracle home that is associated with the ORCLX SID to the 19.3 home. We can copy that simply from the line above that, and then we will paste it, then save the file, and that has completed our manual upgrade. So this is how you can manually upgrade an Oracle database without using the Database Upgrade Assistant GUI interface. So viewers, please provide your feedback in the comment section of the video and hit the like button if you found it useful. That will mean a lot to me and help grow this channel.